Hello everyone and welcome to this section. I'm really excited to talk about artificial neural networks and to explore the power of them in this section. All right, so the first question is, what is artificial neural networks? So artificial neural networks are information processing models that are inspired by the human brain. So simply, we look at our human brain, how human brain works, and we try to imitate that mathematically. Okay, so let's take a look. So what happened here is these are a bunch of neurons in our human brain. And what you see here is kind of like, these neurons are firing. And that's how we actually learn or acquire new pieces of information as we go. And as you guys can see here, this is just an example of one neuron. What happened is these neurons have a list of dendrites, which is kind of the branches going into our nucleus. What happened is we take all these signals within the nucleus, we process them somehow, and then we send the signal out to what we call the axon, which is the outcome or the output of our nucleus. So in a very simple nutshell, what we did, or scientists did, is that they simply tried to look at how our human brain works or how our neuron works, and we try to model that mathematically. So simply, in a very simple form, again, we're going to discuss all that in a lot more details. This is just kind of an introduction lecture to artificial neural networks. We said, that's how our neuron works. Let's actually model that mathematically. And that's what you guys can see here. We have a bunch of inputs going into, we'll assume it's a summation function, for example. We have a bunch of weights in here, and we apply kind of an activation function that generates an output y. That's pretty much how we model our neuron in a mathematical form. Once we have it in a mathematical form, we can then use it, in a microprocessor to actually model our brain, which is really powerful because we're going to learn that artificial neural networks can be used to do many things: face detection, face recognition. We're going to learn how to do traffic sign classification, and so on. So our brain has over 100 billion neurons communicating to each other through electrical and chemical signals. Okay, and these neurons help us to mainly see, think, generate ideas, and so on. All right, and when we say learning, when human learns, that means we try to change the effect of weights, okay, which is simply the values of what we actually can send of these signals here on the axon. So that's how human brain works, or how human brain learns. It learns by creating connections among these neurons, okay? So that's how we model kind of one single neuron in a nutshell. Okay, so in order to build our what we call artificial neural network, or a multi-layer neural network, we actually don't use just one neuron. We actually use several neurons, as you guys can see here. We arrange them in a way that we have a couple of neurons in the input layer, a couple of neurons in the hidden layer, and a couple of neurons in the output layer. And that's how we structure our what we call artificial neural network. Again, the whole idea is we want to build kind of a mini brain, okay, we teach that brain to do whatever we want. We can teach it to classify, for example, pedestrians, classify traffic signs, classify whatever application we want it. And in this section, we're going to learn how to mainly build artificial neural networks. We're going to start again from the basics. We're going to build, kind of a mini brain, one neuron, then build it up a little bit, make it two neurons, build it a little bit more, make it a multi-layer neurons, and we're going to use it to solve practical applications. Okay, this is kind of a quick introduction to artificial neural networks. All right, and let's take a look at how, in general, human learns. Okay, so the idea is we wanted to teach the network to make the network learn in the same fashion as us humans learn. So the first step is, let's see how can we learn. The first step is, let's assume that we wanted to teach a human, for example, a baby. Okay, when you see this image, when you see this car, you put a label that's called, we'll call it car. So we're teaching a kid, for example, okay, once you see this image, okay, this means a car. That's how we try to pose what we call a training data set to humans in general. These kind of inputs, this is what we call a desired or correct output. And what happened is, since babies in the beginning, they don't know, okay, so they sometimes, they mess up. What they do is that they generate what we call a deviated output. They look at this image and they say, okay, maybe that's a horse, for example, okay? What happened is, through experience or through learning, what we do is that we subtract the deviated output, or the error, basically, or the wrong output. we subtract it from the desired or correct output, and we calculate an error signal. And that error signal goes back and actually try to update our neurons' strength or connecting signals between these neurons. And that's how we actually learn as humans, okay? And through experience, this deviated output, you guys can see here, becomes desired output, which in this case, our error turns out to be 0. That means, like when a kid turns, let's say, 4 or 5 years old, now he knows for sure that when he sees this image, that's an image of a car, and that's it, okay? And that's how we learn, all right? What we do is that we're gonna do the exact same thing when we train our artificial neural network. We're gonna actually use kind of this way, what we call it supervised training. We actually pose or like show, for example, the network, bunch of images, okay? These are a bunch of images of a car, and we'll say, okay, whenever you see this, okay, this is a car, and so on and so forth. And we keep doing this, and as we go, we actually try to change, instead of changing the strength of the connection between neurons, what we're gonna do here, we're just gonna change the strength of the weights or the values of the weights. And that's pretty much how artificial neural networks work. And it's really fascinating because it's, it's kind of you're creating your own like, mini brain per se, and you can teach it to do like wonderful things, as we're gonna see in this section. All right? Okay, great. So what are the artificial neural networks advantages? So then one of the key advantages of artificial neural networks is what we call a generalization capability. So humans in general, like if you look at, for example, a self-driving car like this, if you see it from the front, if you see it from the back, if you see it from the side, you can tell right away, without even asking that this is like, this is an autonomous vehicle. I know this by heart. Why is that? Like, even though, you might have seen only the front and only maybe like, let's say the back, but your brain in a way generalizes, assuming, okay, if you show the brain image of this car from a side here, it can actually generalize this too. And that's the power of our brain, and that's the power as well of artificial neural networks, is that we can teach a network to generalize, to improve the generalization capability of these networks, okay? One of the key advantages as well of artificial neural networks is that they are capable of modeling any relationship between a set of inputs and outputs. Actually, this is one of the sayings, like one of the statements, basically a lot of, that appeared in a lot of research papers, is that a neural network with sufficient number of neurons can approximately model any continuous function with an acceptable degree of accuracy. Which means you're going to get the network. I'm going to show you how to build the network in what we call it like a Keras and TensorFlow. It's very, very simple. I'm going to show you with like, like a couple of lines, maybe like 10 lines or so of code, you can actually build your own brain, which is really easy, really fascinating. And that's, again, the power of artificial neural networks, is that if you have training data, okay, you can build the network in a couple of minutes, and actually this network can then learn what you have just taught it, okay? What about the artificial neural networks limitation? The first limitations or drawbacks of artificial neural networks is what we call the black box structure. So again, when we teach these neural networks or artificial neural networks, we have a bunch of inputs. Again, we have a couple of outputs. And what we do is that we train the network using data, okay, using training data. We say, okay, if you see this image of a car, for example, you're going to say, okay, our label is a car. And you keep showing all these images as we go, okay? The problem is, as we train the network, we actually go there and we change the values of the connections or the weights between these networks. Again, in future sections, we're gonna show how can we build this network from scratch. Here is just again a kind of introduction, overview of the artificial neural networks. The problem is, as you train the network, okay, what's happened inside becomes what we call the black box structure, okay? So we don't really know what is the physical significance of, let's say, the weight connecting the first neuron to the second neuron, for example. It's very difficult to identify. And that's why this kind of, one of the limitations is what we call black box structuring. So instead of, for example, of doing physics-based modeling, where you actually know, let's say you're modeling like a mass spring damper system, and you have a mass, you have a spring coefficient, you have a damping coefficient, the parameters within the model are well defined, they actually model something physically in real world applications. Here, it's just kind of a black box structure. You have a bunch of weights, you train them somehow, and that's how you train your network, okay? So even though trained networks can operate properly, the internal structure of the network, which is again the distribution of the weights, often has no physical significance and very difficult to understand, all right? Okay, so let's take a look at a couple of applications. And obviously our first application, which self-driving cars, and that's how we're gonna see how can we teach a network to classify different traffic signs, okay? If you see, for example, like 30 kilometers an hour, you can detect, okay, this sign means 30 kilometers an hour. If you see, let's say, yield sign, you can detect its yield sign and so on. What we could do, we can use it for image classification. We can classify, okay, when you see this, that means a car. When you see this, that means a pedestrian, and so on. We can use it for fault detection and isolation. We can use it for face and speech recognition. As you guys can see, for example, in using Facebook, the auto tagging thing, that's simply kind of an algorithm that looks at your face and detect, okay, this face belongs to, for example, like a specific person or tied to a specific person. We can use it for system identification when you wanted to, for example, obtain a model for a system, and we can use it for control system applications as well. We can use it for fingerprint recognition and hand writing as well, character recognition, along with a lot of business applications too, for stock market predictions and for bank failure prognosis as well. There's a lot of applications. Again, the opportunities are endless. Well, I firmly believe that AI will be empowering a lot of our daily lives in the near future. Actually, we are seeing it happening today with with self-driving cars, with all the face and speech recognition and so on. All right. Okay, so the next step is, what's the plan of attack? So in this module, we're going to start by building what we call a single neuron or a perceptron. Just one simple neuron that simply represents how one neuron in our brain works. And that's how kind of we use it as a building structure. Just like a very simple code. We can see how can we build it first. And then moving forward, we're going to take, okay, instead of having one neuron, we're going to have two neuron models, as you guys can see here. And then we're going to build what we call it a multi-layer perceptron network. We're going to build, like, say, 100 neurons, connect them together. And then afterwards, I'm going to build what we call it a deep neural network, or kind of convolutional neural network. And that's where the type of network we're going to be using that contains a lot of hidden layers that can be used to detect a lot of features. And we're actually going to use it to classify traffic signs. All right. That's all what I have for this section. I hope you guys enjoyed it, and see you in the next section.